Hello students, we are continuing kinematics and we are continuing numericals, motion under gravity. And in previous lecture we have completed some numericals and again we are continuing the same motion under gravity. Lecture number 12. Okay, again the same thing. Let's introduce myself. I am Sachitrakar. Welcome to
KINEMATICS.
Now your doubts. Bring your doubts, please. The first question I am writing on the board. Question number 1. A body is thrown upwards. A body is thrown upwards with initial velocity u. A body is thrown upwards with initial velocity u. Then it is asked, what is distance travelled by the body in the last second of its motion? Find distance travelled by the body in its last second of motion during time of ascent. Okay. A body is thrown upwards with initial velocity u. I am representing the numerical on the board. Body is thrown upward with initial velocity u. We have to find distance travelled by the body in last second of its motion during time of ascent. During time of ascent. Okay. Body goes up. This is ascent. During time of ascent, let this is final position and here velocity of the body is 0. And you have to find the distance travelled by the body. This much distance in last second of its motion. Distance travelled by the body in the last second of its motion. Can you do?
Yes,
any one of you?
Yes, sir.
Oh, fine. Right. You may erase it. Distance travelled by the body in last second of its motion.
Okay.
Very good. You may do here. Okay. Very good. The process is right. I think you have left one sign here. I think. Yes, minus. Okay. It's all right. Answer is distance traveled by the body in last second of its motion is g/2. Then, what's the question? A body is thrown upward with a velocity u. You have to find distance traveled by the body in the last second of its motion. This is last second of the motion. So, time taken by the body thrown from ground when t is 0, the body reaches at the highest position when time is n, and as we know, time of ascent n is equal to u by g. Time of ascent is u by g, as we have discussed in previous discussion, means in lecture number 10. Motion under gravity, the total concept on motion under gravity, time taken by the body to reach the highest position is u by g. So this is n, total time taken by the body, and we have to find distance traveled by the body in last second of its motion. Okay, then the equation is Sn is equal to u plus a by 2 into 2n minus 1. Is it clear? Then Hn means distance traveled by the body in last second is equal to u plus c. Initial direction is positive, upward direction is positive, so g is in vertically downward direction, so g is negative. So this is minus g by 2. Okay, a by 2 minus g by 2 into 2n. In place of n, we may put u by g minus 1. Okay, time taken is u by g. This is right. Now the simple solution, you see it. I am again doing the same thing. So Hn is equal to u minus g by 2 whole into 2u by g minus 1. Then Hn is equal to u minus g by 2 into 2u by g minus g by 2. Sorry, this is plus g by 2. Minus minus plus. So Hn is equal to u. G get cancelled, 2 get cancelled, u minus u plus g by 2. So our final answer is g by 2. If you take value of g is 10 meter per second square, then 10 divided by 2, then final answer is 5 meter. Okay. So final answer is g by 2. The body is thrown with velocity u. Then my question to you, will the answer change if value of u change?
No, sir.
Okay. You may take u is equal to 5 meter per second, you may take u is equal to 10 meter per second, or you may take u is equal to 100 meter per second. Whatever may be the value of u. Whatever may be the value of u. The final distance means distance travelled by the body in last second of its motion during time of ascent is independent of initial velocity of the body. Is independent of initial velocity of the body. Again, another concept, symmetry of gravitational motion under gravity. Very important theory. You see, suppose a body is thrown from ground and comes back to the ground again. Body is thrown in upward direction and finally it strikes on the ground. Okay, this is highest position. When the body reaches at highest position, its velocity becomes 0, and when the body again starts from highest position, its initial velocity becomes 0. Okay, so this is last 1 second of the journey, and this is first 1 second of the journey. Okay, so this last 1 second journey during time of ascent is g by 2, and obviously I can prove it. The distance travelled by the body in first 1 second during descent is also g by 2. in last 1 second during time of ascent, last 1 second distance is g by 2, and while descending in last 1 second again distance is g by 2. If you consider the body is descending down, means body is moving down, then let's take it h. H is equal to ut plus half gt square. Here time is 1 square. Again h is equal to j by 2. So distance travelled by the body in last second of its motion during time of ascent is equal to distance travelled by the body in first second of motion during time of descent. Okay, and finally a small idea on motion under gravity, means symmetric. You see, suppose a body is thrown upward when time is 0. This is 1 second, this is 2 seconds, and this is 3 seconds, and finally this is 4 seconds, and here velocity becomes 0. And this is 5 seconds, this is 6 seconds, this is 7 seconds. Okay, then this distance means distance between 3 seconds to 4 seconds must be equals to distance between 4 seconds to 5 seconds. And obviously distance between 2 seconds to 3 seconds is equal to distance between 5 seconds to 6 seconds. Distance between 1 second to 2 seconds must be equals to distance between 6 seconds to 7 seconds, and these two are also same. This is called as symmetry of motion under gravity. Next doubt. Next doubt, please. Very good, Prachi. A ball is thrown upward from the ground. The ball is at a height of 80 meters for 2 times. The question is not clear. Please bring your copy. Is a paper. In paper you have not written clearly. Okay. A ball is thrown. Okay, this is clear. A ball is thrown upward from ground. The ball is at a height of 80 meters for 2 times in an interval of time 6 seconds. This is the concept. Okay. Let me represent first, then I will solve. Next question. A ball is thrown upwards from ground. This is ground. A ball is thrown upwards. Let velocity is u. The ball goes up and again comes down. Okay. The ball is thrown upwards from ground. The ball is at a height 80 meters for 2 times. Let this height is 80 meters. This height is 80 meters. This is h. So the body goes up and again comes down. And this height again from ground is also 80 meters. This is during upward motion and this is during downward motion. The ball is 2 times at the same height from ground, and interval of time as it is mentioned 2 times in an interval of time 6 seconds. See, from this position to this position, from this position to this position, time is 8 seconds. Okay, the ball is at a height 80 meters. 2 times the interval of time is 8 seconds. Okay, then what is asked? Find the value of initial velocity. We have to find value of u. This is asked. See, this is displacement from ground. This is also displacement from ground. Then use a single equation. Very easy. You will get a quadratic equation and solve for u. Because time is given, time is 8 seconds. The general equation AC is equal to ut plus half at square. Displacement is 80. In place of s, we can take 80. Initial direction is positive, so u is positive is equal to ut. T is 8 second ut plus half in place of a initial velocity and acceleration due to gravity are opposite in direction. So initial direction is positive and opposite to initial direction is negative as per our convention. So you may take minus g means minus 10 at square t square. So at is equal to 8u minus 5t square. This is our equation. You can solve now. This is quadratic equation, and solving it you will get time. Of course you may write the complete form. Now solve it. 80 is equal to 8u minus 5t square, and it is asked to calculate initial velocity. Of course you may take it 5t square minus 8u plus 80 is equal to 0. This is in quadratic form. Okay. Now you may solve for t. 5t square t is 10t square t is t square. Okay. 5t square, then it is easier. For time you may solve now 8u. So u is kept unknown. Time we know. We may put this value in later stage ut. Of course you now use this t. ut. This is ut. So this is ut. So that we may take time as unknown quantity, but we know the value of time. So quadratic equation, this form will give us answer about time. So take time as unknown quantity, and finally we will put the value of t. Then from this equation we can get t is equal to quadratic equation minus u means plus u plus minus square root of u square 2ac minus 4a. A is 5, c is 8. Okay, divided by 2a. A is 5, this is 5, thus t is equal to u plus minus square root of u square minus this is 20, 1600 whole divided by 10. Then you will get two values of time. T is equal to u plus root of u square minus 1600 whole divided by 10, and taking negative sign t is equal to u minus root of u square minus 1600 by 10. This is taken as t1 and this is t2. See, to reach this height, time is smaller. The body directly projected from ground and reaches at a height 80 meter. So this time is smaller time, this time is t1. And again it moves up and then moves down and reaches here at the same height 80 meter. So this time, for this position, time is t2. This is longer time and this is shorter time. Okay. Now it is very easier. You know the value of time. Time is 8 second means interval of time is 8 second. Means t2 minus t1 is equal to 8 second. Longer time minus shorter time is equal to 8 second. Now you can solve it. Can I erase it now?
Yes, sir.
Okay. T2 minus T1 is 8 second. Then in place of T2 we may write u minus root of u square minus 1600 divided by 10 minus T1 u plus root of u square minus 1600 divided by 10. Now you can solve for u. It is asked and you have written the answer. Answer for u will be 50 meter per second. The sound. Answer for initial velocity is 50 meter per second. You can solve it easily. Okay. Next question. Okay. With this question, a body falling from a height. This is your question. Okay. A body falling from a certain height, describe half the total height in last second of its motion. This is your question. I think you can do it. This is easier question. Okay. I am writing the question. A body falling from a certain height covers half the total height, in last second of its motion. Find height of fall. Okay. I've changed the language a little bit. Okay. Body falls from a certain height. Let this is a tower. This total height is h. Body falls from a height h. We have to find this height. When a body falls, means a body released. The body is held here and released. Can you say me? What is the initial velocity of the body?
0.
0. Very good. Initial velocity of the body is 0. And here acceleration is due to gravity, that is g. Then motion is accelerated or retarded?
Accelerated.
Accelerated motion. Okay. Then velocity will go on increasing. Okay. And it is given h and distance travelled in last second, means if the body is released from the top of a height at t is equal to 0, then to reach at ground, time taken is n second. Total time is n second. And here given distance travelled in last second. This is distance travelled by the body last second of its motion. It is given that half the total height, means distance travelled by the body in last second is half the total height. Total height is h, then distance travelled by the body is h, and this is h by 2, not too small. h nth. This is h nth. This is h nth, and this is equals to h by 2. Clear? Then just use the formula for h by h nth. H nth is equal to u plus g by 2 into 2n minus 1. Because motion is downward, acceleration due to gravity is downward. So initial direction is positive. So h nth is h by u is equal to 0 plus g by 2 into 2n minus 1. 2 get cancelled. Now our aim is to first get what is m. Our aim is to get m. What is m? H nth is equal to u plus g by 2 into 2n minus 1. Certain height is h is equal to g by 2. G means it's like g by 2 into 2n minus 1. H nth is equal to u plus a by 2 into 2n minus 1. U is 0. G by 2 into 2n minus 1. Okay. This is mistake. G by 2.
So 2 were cancelled.
Okay.
So
This one.
here 2 is
H is equal to G by 2 into
H is equal to G to n minus 1.
Okay, this 2 is cancelled. Okay, thank you. This 2 is cancelled. So H is equal to G into 2n minus 1. Okay, but what is actually H? Total time is n. AC is equal to, just use the equation, AC is equal to ut plus half at square. Total distance is h, u is 0 plus half. In place of a, you may use g. In place of t, this is n square. So in place of h, you may use half gn square. Half gn square is equal to 2gn minus g. Okay, now solve it. G get cancelled. N square by 2 is equal to 2n minus 1. So again you have to solve. N square is equal to 4n minus 2. So n square minus 4n plus 2 is equal to 0. Is it clear? Now solve for n. Now solve for n. Then solve for n. Quick. I will not solve. What will be the answer? What will be the answer? Quadratic equation, you may solve it. Will I erase it now?
Yes, sir.
Okay.
So 3.145.
N will come?
3.145.
Very good. 3.145. This is n. Then total height is half gn square. So h is equal to half. You may put 9.8 into 3.145 square. Now solve it. And final answer, I think it will be
56.9.
You know the answer, right?
Yes, sir.
So this is total height of the building. And quadratic equation, you may solve it very easily. Okay. So we shouldn't give much time behind it. Okay. Next question. Next question. Okay. From the top of a very good question, a beautiful question, I think, and this may be challenging question and good question also. I am writing the complete form of question. From the top of very good question, have interest behind it. From the top of a tower, a stone is thrown up. A stone is thrown up, and this is up, and reaches the ground. In time t1. From the top of a tower, a stone is thrown up, means in upward direction, reaches the ground in time t1. Okay. A second stone is thrown down with same speed and reaches the ground in time t. Okay. A third stone, again another stone. A third stone is released released from rest and reaches the ground in time t3. Okay. Oh, this is an objective base. You have given the options. Option A, t3 is equal to half in t1 plus t2. Bit B, 1 by t3 is equal to 1 by t1 plus 1 by t2. C, bit C, t3 is equal to square root of t1 t2. Bit D, t3 is equal to t1 plus t2 by 2. Okay, this is your question. Then first understand the situation. A stone is thrown from the top of a tower. Let with a speed u. It goes up and finally strikes the ground. Time taken is t1. A second stone is thrown downward from the same point with same speed. It reaches the ground in time t2. And third stone is just released. It reaches at time t3. Then we have to establish a relation between t1, t2 and t3. Okay. These are your options. I am erasing the question because space can't be provided. Option A, t3 is equal to half into t1 plus t2. Option B, 1 by t3 is equal to 1 by t1 plus 1 by t2. Option C, t3 is equal to square root of t1 t2. Option D, t3 is equal to t1 plus t2 by. Okay. I do describe the situation. You can understand it well. Okay. This is the height. Let this height is h. Okay. First case, a stone is thrown upwards. Let with a velocity u. When time is 0, a stone is thrown upward. It is moving upward and again moves down and reaches some ground. Time is t1. Another stone is thrown with same velocity u and it reaches the ground at time t. And another stone is just released from rest, means its initial velocity is 0 and it reaches the ground when time at time t3. Then we have to establish a relation between t1, t2 and t3. Okay. Then for first stone, first stone is thrown in upward direction with a velocity u. It goes up and again comes back to ground. Okay. Initial direction is positive. We have already done such type of question. Okay. The stone is thrown upward, so upward direction is positive. Downward direction is negative. Initial direction is positive. Thus for first stone use the equation AC is equal to UT plus half AT square. See, the stone starts from the top of the building and reaches on the ground. So vertical displacement is H. This is initial position and ground is final position. So vertical displacement is H. H in downward direction. So in place of S we may take minus H. U is positive in upward direction. U. Time is T1. Acceleration due to gravity is in downward direction, means opposite to initial direction. So minus half G T1 square. Okay. So we may change the sign by multiplying negative sign on both sides. For second stone is thrown with a velocity u in downward direction. So initial direction is downward. Again using the same equation. Here downward direction is positive h. Initial velocity is u. Time is t2. Again acceleration due to gravity is downward, means along the direction of motion, means initial velocity plus half g t2 square. This is for second stone. Okay. For third stone, this is first stone, this is second stone, this is third stone. For third stone, initial velocity 0, it is released from rest. Again equation. For third stone, h is equal to ut plus half gt square gt3 square. Is it clear? This is for first stone, this is for second stone, this is for third stone. Now you have to establish a relationship between T1, T2, T3. Okay. Now you solve it, it is very easier. You can solve it now, and after solving you will get, I know the answer, T3 is equal to square root of, this option will be correct.
Yes, sir.
Can we solve it? No. See, you see the situations what you have asked me. First stone is thrown upwards with a velocity u. Second stone is thrown downward with same velocity u. Third stone is dropped with initial velocity 0. So I have used 3 equations. Okay. And for first stone, see, if you feel difficult, see, h is equal to minus ut1 plus half gt1 square. Just multiply negative sign on both sides. Okay. And for second stone, it is correct. No requirement to change the sign. This is second equation. And third equation, simply you may write half g t3 square. Okay. Then what similarities do you get? This is h. Sorry, this is for first stone. This is h. This is also h. This is also h. So value of h is same. Displacement is same. Just use. It is asked t3 is equal to half t1 plus t2. 1 by t3 is equal to 1 by t1 plus 1 by t2. Okay. Now we may solve it. We may solve it. So this is equation 1. This is equation 2. And this is equation 3. Is it correct? Okay. Now you may find u. You may find u. ut1 here, just see ut1 here, u22, ut2. Just equate these two. This is h. This is equation 1. This is equation 2. This is h. This is also h. Equate right sides. Minus ut1, or you may take this equation, ut2 plus half gt2 square is equal to minus ut1 plus half gt1 square. This is equation 2, this is equation 1. From this equation, this is equation 1. Equate these two equations. H is equal to h. So equate right side. Now bring it to left side. U into t1 plus t2, and bring it to right side. Half g into t1 square minus t2 square. From equation 1 and 2, you got this. Okay. Then about t3 means equation 3. Equation 3. U into t1 plus t2 is equal to half g into t1 square minus t2 square. So u. Okay. T1 square minus t2 square. I am writing again. T1 plus t2 is equal to half g into t1 plus t2 into t1 minus t2. Clear?
Yes, sir.
So u is equal to half g into. Is it clear?
Yes, yes, sir.
Then u is in equation. This is u. We got u. This is also h. This is also h. So u is equal to half g into t1 minus t2. Now use it in equation, suppose 2. Let's take equation 2. Okay, can I erase it now?
Yes, sir.
Okay. Where to go? This is only space. So use it in equation 2. So in place of h, this is h. In equation 2, this is h. H is equal to u. In place of u, you may write half g into t1 minus t2 u into t2. In place of u, you just put it into t2 plus half g t2 square. Is it clear?
Yes, yes, sir.
Is it clear?
Yes,
Then
sir.
you may solve it now. H is equal to half g t1 t2 minus half g into t2 square, or more simplification is required. Okay. H is equal to half g t2 into t1 minus t2 plus half g t2 square. Is it clear? Now multiply it. So h is equal to half g t1 t2 or t2 into t1. Same thing. Then minus half g t2 into t2 means t2 square. Is it clear?
Yes, sir.
Again plus half g t2 square, both get cancelled. So h is equal to, see, the question is simpler now. t1 t2, keep it. Then we have not used equation 3. We have not used equation 3 till now. From equation 3, h is equal to half g t3 square. Okay, this is h, this is h, equation. This and this are same. Now equate right side. Half g t3 square is equal to half g t1 t2, half g get cancelled. Okay, so t3 is equal to square root of, again another right mark. Okay, too simple. Just try to solve the equations using equation 1 and 2, and whatever you get from equation 1 and 2 equate with equation 3. Now it is completed. Next question. The body is dropped from a balloon. Okay, this is a traditional question. So almost all teachers are doing all this question, a traditional question. I will go to the data in later stage. I am first explaining about the concept. Okay. A body is dropped from a balloon ascending with a velocity 5 meters per second. This is a balloon. Okay. Ascending means balloon is moving up with a velocity u is equal to 5 meters per second. This velocity is constant. Ascending, understand the concept. The balloon is ascending. A balloon is ascending with a velocity of 5 meter per second, a stone is dropped from it. When I am changing the sentence slightly, but theme will be same. When the balloon is at a height, I think this must be mentioned in your question. Body is dropped from balloon ascending with velocity 5 meter. The body is, not height is not given. Dropped from it. Okay. The body takes 10 seconds to strike the ground. Okay. The body, or I have taken a stone. The stone takes 10 seconds to reach the ground. The stone takes 10 seconds to reach the ground. Okay. Okay, this much question, then we have to find from what height the stone was dropped. Or you may ask me, when the stone strikes the ground, what is distance between the balloon and stone? Different questions may arise. Let's first find a stone is dropped from the balloon. When the balloon is at a height h from the ground, a stone is dropped from the balloon. The stone is dropped from the balloon. See, our previous concept, if a body is dropped, suppose a body is dropped, what is its initial velocity? 0.
0.
Okay. But here, initial velocity of the stone is not 0. Why? Because balloon is moving with velocity 5 meters per second. The balloon is in motion. The balloon is in motion while the stone is dropping from it. So due to inertia of motion, the stone will not move down fast. Due to inertia of motion, balloon is in upward motion. So stone is dropped from it. You just think. You suddenly jump from a moving train. Don't jump like that. Suppose you suddenly jump from a moving train, train is moving slowly. Then you have to run along the direction of the motion. Otherwise you will fall. Because you were inside the train. The train was in motion. You were in motion. So your body acquires inertia of motion. If you suddenly jump from the train and stand there, you will fall along the direction of motion. Okay? We'll discuss it in laws of motion and you know it previously from your basic standard. Since the balloon is moving up, initially the stone will move up with same speed u. But when the stone moves with same speed u, acceleration due to gravity will oppose its motion. The stone will move up and velocity of the stone becomes 0 at a certain height. Then it will fall and strike the ground. See, this is initial position of the stone. This is final position of the stone. So displacement means vertical displacement of the stone is also h. This is initial position, this is final position. So vertical displacement is h. Okay, but velocity in upward direction, displacement in downward direction, initial direction is positive. So upward direction is positive, downward direction is negative. Okay, now you use the simple equation AC is equal to ut plus half at square. Here displacement is h. In downward direction, it is positive or negative?
Negative.
Negative. Okay. Minus h. U is positive or negative?
Positive.
Because initial direction in upward direction u. t. U is 5t plus half. G is a downward is negative, minus G means minus 10 into t square. So minus h is equal to 5t. Time is given 10 seconds. Minus half into 10. Time is 10 seconds means 100. So minus h is equal to 50 minus 500. So h is equal to 450 meters. So when the balloon was dropped, when the stone was dropped, the balloon was at a height of 450 meters. Time taken by the balloon is 10 seconds. This is first answer. So if it is asked, when the stone strikes the ground, what is distance between balloon and stone? The balloon takes 10 seconds to reach the ground. In that time, the stone takes 10 seconds to reach the ground. In that time, the balloon is not at rest, it has moved up. In 10 seconds, let the balloon has reached at this position. Then distance travelled by the balloon, let small h, then h is equal to u into t, because speed of the balloon is constant. Speed of the balloon is constant. See, question may come to your mind, how balloon is moving with constant velocity, gravity may retard its motion, but no. After neutralizing effect of gravity, gravity is pulling down, but balloon gives a force in upward direction. Okay, you may take helicopter, you may take balloon fitted with or provided with gas. Okay, after neutralizing gravity, the velocity is u, means u is constant. Okay, so balloon has travelled a distance u. U is 5. Okay, again time is 10 seconds. Balloon has travelled a distance 50 meters. So distance between balloon and stone is total distance h plus h, that's equals to 450 plus 50 is equal to 500 meters. Is it clear?
Yes, sir.
Okay. Next doubt. Fine. A body of mass 2 kg is released from, not at, Sunita, not at. A body of mass 2 kg is released from the top of a smooth inclined plane. It means we have neglected friction. We are neglecting friction. Smooth. Okay. Smooth inclined plane having inclination 30 degree takes 3 seconds to reach the bottom. Takes 3 seconds to reach the bottom. If angle of inclination is doubled, okay, let's discuss first what is the nature of motion. See, we will discuss in brief in friction, laws of motion, etc. Here only you should have idea on motion on inclined plane. I have discussed the theory in previous theory concept motion under gravity. This is inclined plane, this is horizontal plane, and this is vertical plane. Vertical plane, horizontal plane, inclined plane. Suppose angle of inclination is theta. A body is released from rest from the top of the inclined plane, then obviously the initial velocity is 0. Then as we have discussed in previous lecture number 10, here acceleration is g sin theta. G sin theta. Okay, we have discussed it. You may follow the free body diagram. This angle is theta. This is a body. Weight of the body always in vertically downward direction, and the surface gives reaction, normal reaction. This angle is theta. This angle is theta. This component is mg cos theta. Mg is a force, and another rectangular component parallel to the plane is mg sin theta. So force acting on the body in downward direction is mg sin theta. So force by mass is acceleration. So acceleration is g sin theta. Weight vertically downward. Normal reaction perpendicular to the plane. If this angle is theta, then this angle is theta. Then component of mg perpendicular to the plane is mg cos theta. Component of mg parallel to the plane is mg sin theta. So force is mg sin theta. Force by mass, mg by mass, mm get cancelled. Thus acceleration is g sin theta. Is it clear?
Yes.
Okay. The body starts its motion when time is 0. The body reaches at the bottom when time is t. Let this distance is s. Then use the equation. S is equal to ut. U is 0. Okay. Plus half at square, in place of a, we may write g sin theta into t square. So time is given as root of 2s by g sin theta. This is your concept. And now your question. I have not gone through your question. A body of mass 2 kg. A body of mass 2 kg. Body of mass 2 kg is released. Released means I am writing symbolically u is equal to 0. Released from the top of an inclined, smooth inclined plane. Okay. No need to write the question, I think. Okay. No need to write. Her doubt is very common doubt, and I have already explained, so you can understand well. The body is released from the top of the inclined plane. Means initial velocity is 0. Okay. Having inclination, let theta 1 is 30 degree. Initial inclination is 30 degree. Okay. And it takes time, when theta is 30 degree, it takes time t1, that's equals to 3 seconds. Am I right? Okay, 3 seconds. If angle of inclination is doubled, if angle becomes 60 degree, then it is asked what will be time? Very simple. When angle is 30 degree, time taken by the body to reach the bottom is 3 seconds. When angle is 60 degree, what is time taken? Okay. See, AC is constant, 2 is constant, G is constant, so time inversely proportional to square root of sin theta. Okay. Then simply T2 by T1, T2 by T1 is equal to square root of sin theta 1 divided by sin theta, inversely proportional. T1 proportional to inversely proportional to root of sin theta 1, T2 inversely proportional to root of sin theta. Okay. Then T2 by T1, T1 is given 3 seconds. Root of sin theta 1 is 30 degree. Divided by sin theta 2 is 60 degree. Then T2 by 3 is equal to square root of sin 30 is 1 by 2, sin 60 is root 3 by 2, 2 get cancelled. Okay. Then it will come. Then now you can get T2. 2 get cancelled. 2 get cancelled, and I think you have given your answer. T2 by 3 is equal to now you can calculate T2. Root 3 by 2, sin 60 is root 3 by 2, Again, whole root is there. Okay, whole root is there. Side shift is root 3 by 2. Is it clear? So this will come 1 by root 3. Whole root of 1 by root 3. Then T2 is equal to 3 into whole root of 1 by root 3. Is it clear?
Yes, sir.
Okay. Next. Okay. This is the question motion in liquid. And I think we have discussed the concepts. If a body moves in a liquid in downward motion and if a body moves in a liquid in upward motion. Let's see. Good question. A solid ball. A solid ball of density. A solid ball of density half that of density half that of density of water. Okay. Half that of density of water falls freely under gravity from a height of 19.6 meter and then enters in water. Up to what depth? Up to what depth will the ball move? This is your question. See, the first data is the solid ball of density half that of density of water. Then if a ball or body has lesser density as compared to water, then the body will sink or the body will move up. This is first question. If density of body is more than density of liquid, then the body will sink. Means downward force will be more than that of upward force. If density of body is less than that of density of liquid, then the body will move upward. But this is a different situation. See, this is surface of water. The body is dropped, means initial velocity of the body is 0. What is the height? Height is 19.6 meter. Okay. When the body is dropped, it strikes water. It strikes water surface with a velocity, let V1. Then V1 square is equal to U square plus 2GH, motion under gravity. Then V1 is equal to V1 square 0 plus 2GH. V1 is equal to root of 2GH and V1 is equal to root of 2G 9.8. H is 19.6. And when the ball enters into the liquid, it will come, see, 9.8 into 2 is 19.6 into 19.6, then V1 is 19.6. This is initial velocity. Now, when the ball moves inside the liquid, the upthrust will act in upward direction and weight of the ball in downward direction. And we have already discussed this concept. Okay? And the ball, since upward force here, upward force is more than that of weight because density of ball is less than that of density of water. So, this motion is retarded. Finally, the body comes to this position and final velocity becomes 0. And this is the depth. This is the depth through which the body has traveled. Then, as we have discussed, Here retardation, not acceleration. Here retardation. What is formula for retardation? See, I am doing here again. Upward force weight, downward force weight. So resultant acceleration means retardation is equal to upward force minus downward force by mass. So resultant acceleration in upward direction means this is retardation. Force is density of liquid, volume of displaced liquid, that's equals to volume of body into G minus weight, density of body, volume of body into G, mass of the body, density of body into volume of body into G. Sorry, density of body into volume of body. Okay, B get cancelled. Then it comes rho L by rho B minus 1 G, bring it common. Then density of liquid means density of water. Density of water. Solid ball of density, half the density you take. This is density of water. And density of body is half the density of water minus 1 into G. So it will come 2 minus 1. So G dash is equal to G. Is it clear? G dash is equal to G. Now, through what depth the body has travelled? Final velocity is 0. V square is equal to U. Here U is V1 square minus 2. Acceleration is G dash. Displacement is S. Final velocity is 0. Okay. Is equal to V1 square minus 2 G dash S. So, displacement means total distance travelled by the ball is V1 square by 2 G dash. V1 square, V1 you got 19.6 square divided by 2 into G dash is G means 9.8. 2 into 9.8 is 19.6. So S is final answer. S is 19.6 meter. Is it clear?
Yes, sir.
Very good. And this is end of lecture 12. And in next lecture we will discuss a very good concept, kinematics graphs. Thank you, my dear children. Thanks.